Medical physics and biomedical engineering is a fundamental part of hospitals and healthcare. Without it, there'd be no MRI scanners, no radiotherapy units, no dialysis, no pacemakers and so on. A medical physicist is someone who uses their knowledge of physics to solve problems in healthcare, whereas a biomedical engineer will use their skills in engineering and in design in order to tackle largely the same problems.
When I was in the sixth form studying as an A-level student, I had an interest in medicine and everyone told me I was going to be a doctor. And it was the talk that I heard about medical physics at the London International Youth Science Forum that made me realise there was another way of using my interest in medicine and switched me from a career path in medicine to medical physics, and that's a decision I've never regretted.
So here at UCL we believe that research-based education is a very good way of giving students the technical knowledge but also the context while learning. And that is something that we embrace in the biomedical engineering program. And it's actually quite easy because our department is brilliant in terms of research.
I think it's very important that our students are taught by people working in the state of the art. So our lecturers are world-leading, nationally leading scientists in their own right, telling them about what's going on in discipline right now.
I think we give students a variety of skills across the board, from theory to equations manipulations, all the way to the design and constructions of systems and machines that work. So it's a varied mix of skills. We're strongly interdisciplinary. We're at the interface of physics, maths, medicine and engineering. And typically then you can look at jobs in research, academia or other research institutions. You can look at jobs in industry or the health services, for example, the NHS.
So during the first week, the students will be doing an in-class activity which is called Pebble in the Pond. The aim of the activity is to deliver a pebble from one end of a table to the other. The learning objectives of it are much greater, and it gives the students the experience of working in teams for first time that we can discuss later on in the class.
This department just allows you to meet so many different people from different backgrounds, and it's kind of like a little family in a very strange way. And then in terms of the actual work itself, you generally get a lot of support to try lots of different things. So as a physicist, I've now delved into radiation biology.
The other thing I really appreciate is the fact that you can start cross-disciplinary collaborations with other departments. So for example, for my project, I've been working with a group based at the Institute of Neurology.
What I love most about working in this department is that you're faced with new challenges all the time in terms of physics and biomedical engineering. You never quite know where the next project's going to come from and quite how that's going to involve you in different collaborations that you may not have thought of before.
What I like best is that we are still a reasonably small department. We know everybody, we know each other very, very well. We like our students, we have the time, we have an open door office, and we take the time to speak to them.
We tend to attract students who are interested not just in science as a discipline, but in how it can be used to benefit society, and particularly how it can help development of new techniques in healthcare.